Start.
Hello, my name is Dominik. I work at Talk. I'm also the committer of Apache Aries, and there are some contacts on the side that you can check, for example, my code in the internet or check some of my thoughts. And today I would like to talk about integration testing, how to write good integration tests and what to avoid when we are writing such tests. First, let's start with the test types. We have a lot of them in our environment, in our projects. So, for example, we have unit tests, integration tests, end-to-end tests, and there are the main group that we are using during our software development. Of course, we are adding another type of testing, like performance tests, manual tests, smoke tests, and so on and so forth. But today we are going to focus on integration tests. Integration tests is a level of testing where we are testing the combination of the components that we have already probably tested via our unit tests, and we are checking what are the problems in the integration between them, how how they work together in a group, and where could be a problem in the communication between them. So, for example, you could have an application where two units works perfectly, but if you combine them, then it will be a problem. And for example, such a problem could occur on production, and we want to avoid such things. If we look at our application, in the middle, we have our application, and around that we have a lot of components that we are talking to. For example, we could talk with database, with HTTP service, also HTTP, and we could expose the HTTP service. Maybe we are also talking with messaging systems or file system to, for example, create some file or read some file. Inside our application, we also have a lot of components which talks with each other, and such combination also has to be tested in our tests. And there is also the question, how many integration tests should be in the application, in the project that we are writing? I have found two approaches to that problem. One is test pyramid, and in such approach, at the bottom, we have a lot of unit tests for each unit or module, whatever you call it in your application. You add some tests, some tests only for that module, and then you add some integration tests, which combines them and use them together. And we are grouping. For example, we can use 2 of them, 3 of them, and also we have end-to-end testing, where we can combine all the components that we have in our application. For example, also with the microservice infrastructure, we can run all the microservices that we have in our application to check if everything working as expected. But of course, the amount of such tests is much lower than the amount of unit tests. Another approach that I have found is test trophy. This is something that has been invented by Ken C. Dodds in his article that write tests, not too many, mostly integration. This guy is connected with the React component testing. And for example, in his article, he proposed such way of dividing the tests, where at the bottom we have some static tests, where we, for example, could test something with linters, with compilers, transpilers, whatever is we have. Then we have some unit tests, but the amount of unit tests is not as big as we use in normal business application, as we use in a pyramid approach. But we have a lot of integration tests because we are integrating a lot of small React components, for example. And we also have to interact with the browser and similar things. And it's more crucial for our application. So we have a lot of such integration tests. Then we could have, of course, some end-to-end tests. So if you want to know the answer, how many integration tests should be in your application, I think it depends on you, it depends on your project, on your problem, but there should be at least some integration test if we are really, if we can work with the production environment that we will have on production. Yeah. Okay, let's start with some common fix connected with all the tests and especially with the integration tests. How the good test should look like. First, in my opinion, it should be correct. So it should check the correct things with and should connect to the correct external things, for example, which we are interacting with. Also, such tests should be as fast as possible, to not that we are not afraid to add another test to our set, and for example have tested all the components that we have in our application. Tests also should be very readable, and also the section, the name of tests, everything connected with naming in the test. The level of abstractions should be readable, should be written in a good way. And tests, especially the integration tests, where we are testing the communication between components, such tests should build some kind of story between the components, and where we can find where we are in our path, in our history of our product. And also the tests should create a good report, for example, to check if we passed the test, if we didn't pass the test, and how many tests didn't pass. Okay, for the first point, tests should be correct, and it means that for the integration test, we should use as many production components as possible, because when we are testing against some mocks, against some, I don't know, fake objects, it doesn't test the good thing. Yeah, we are testing more the mocking software or some other software written just for our test. We should test with real database. For example, if our production system works on Postgres, then why do not test it on Postgres? Of course, we don't have to test every component with the Postgres. We could have some small amount of tests which really integrates with Postgres, and some of them could also test with the mocking. Yeah, but have at least one test with the real component that you are interacting with. If you are testing against, for example, Postgres or any other database, then use such external component in a correct production version, because we often test something in our environment in the newest version, but on production we have quite old version, and there could be some problems on the communication layer between us and other softwares. Such external things that we have to install in our environment and in our test environment especially, but it could be embedded in our application. For example, in Java, it's quite easy to embed MongoDB or Kafka Broker. We could also take advantage of Dockers, and for example, in Java, we have test containers which grabs and wraps the Dockers in themselves. So, for example, if you want to choose some Docker or test container, you have a lot of them, probably for any component which is well known in the internet, like any database, any broker, or any server that is available. And to use it, for example, in Java, in JVM Word, you can add only one dependency. For example, for test containers in Postgres, create special connection string to the database where you set the Postgres database and version of such Postgres database. And additionally, you can even add the initial script for such Postgres database, and the database will be created in Docker just for you. You can take advantage also of the API that is provided by test containers for creating Dockers in your test at the beginning of your test, and such Docker will be turned off at the end of your test. Another approach is to have something installed natively on your system. So, for example, of course, you can install it on your machine during the test. It's not just easy to run your CI script or whatever you have to test your software. You have to have some additional installation, additional configuration to run such software and test it. But another approach is to have something installed remotely. For that, you need a specific namespace, whatever it is, a schema, port, scope, whatever you can call it in the external system. And it's, for example, installed in one of your data center. You, during the test, probably need also some VPN or Ethernet access. So it's not easy to run such tests, for example, when you are in the train. And it could be a bottleneck, because when you are interacting with shared database, which can be used by many users testing in the same time, then, for example, someone could run very expensive query and your test will be much slower. You can say that no one uses this approach. I remember that I have had used this approach when we were testing against TSM library, where we are performing some operation on the TSM library, and only way to check if our commands are proper, are working in the expected way, is to check if the robot in our data center was checking the good things in and for example takes the good state from the library. With such approach, where you have something installed natively, it's not easy to have multiple versions, because yeah, it takes time to for example install another Oracle, install another Kafka system, and so on and so forth. With Dockers, it's much easier. You just download another image and it's already installed in the container. Nice thing to have in the test is unique or random test data, because when we are using unique test data, then our data cannot be shared by any other test. Our data are unique only for our test. Thanks to that, our test could be run in parallel, and we are not interacting with we cannot interfere any other data available, for example, in database. For that, we could use, of course, UUID, maybe random numbers generator. It's nice to have seed written logged in some way in your test suite at the beginning of test suite, to check what is the seed, and if you want to run the test one more time, then you can run it with a specified seed and check what has happened during the data creation and why the test didn't pass. Another things to have with such data generation is to have some prefixed data from specific cases. One, you can add, for example, test XXX at the beginning of the test to mark such data that those data belongs to your specific test. You can also have some static parts to test, for example, Polish letters in some text to check if you are handled in the correct way. You have a lot of things that are common in your tests, so it's also nice to have some common helpers grouped in some library, maybe in some module, depending how you are dividing your software. So you should have some builder, for example, for data generators, time helpers, DB access, and so on and so forth. And the last point, if you have a hammer, everything looks like a nail. So I remember the case where in our integration test, we were using Gatling because someone was very affected by the Gatling. Gatling is a tool in JVM for performance testing, and it has very nice HTTP API, but it's not good idea to use them in our integration test, because the report that is generated for such tool is unreadable for machines. You have to parse them manually and check what has happened. So yeah, it's not a good idea to use such tool for just for use in another things. Okay, when you are testing between your components, you have to grab a lot of or some of the components that you have in your application to check if they are working together. So for example, imagine we have component A, and component A is talking with component B in some way. If you look at such such image, the communication between them is pretty easy. Yeah, it's probably it could be the Java call or object method call on whatever it is in your language. But under the hood, it could be something different, because in between could be also something different, like HTTP call. Maybe this is the queue. You have a queue in between. Maybe there will be some database or something similar. So you have to test the whole configuration where component A is integrating with component B with any communication medium that you have in between. For such tests, it's nice to have to hide all the implementation details. So on this slide, for component A, you have a specific, for example, DI configuration. For component B, you have another production DI configuration. And the whole test is also grabbed in one configuration where you take advantage of those two and reuse those two configurations, and additionally configure in a specific way the connection between them and the other components that are available. And such components, for example, component A and component B, also need some other things. And here we are focusing on the integration. So between our components, we are using the same thing that we are using in production, but another dependencies, another modules that are needed for such tests could be mocked. Yeah, of course, we could use the real collaborators in such way, but maybe it's easier to, for example, not focus on them and add some dummy object or some fake DB for do not spending time or checking what's going on in such integration. And we can test, of course, such parts in another integration test that we have in our suite. Okay, the first thing that are external for our system and we are often integrating with is the time. And problem with time is that we often use real time in our test. And if we are using real time, then in our test, we can spot a lot of thread sleeps. And thread sleep are code smells that we should avoid in our test. The rule of thumb is avoid waiting unconditionally. So if you spot such things, then replace with some pitch better. But to do it, you have to have your code written in a better way, probably. So, for example, you can inject the time to all the methods that are using the time, getting the time from the system. So instead of getting the instant from some static methods, which you probably cannot mock in any way, then you can have special interface just for that, where you have another implementation on production, another implementation on during your test. Or you can, for example, in Java, create a clock object and pass such clock object to such instant. As I said, in production environment, it will be set to the system clock with special, for example, time zone in Java. And during your test, it could be fixed clock with a specific time period with the specific definition of now. And thanks to that, when you injecting the clock to all your tests, then each test has its own clock, then all the tests doesn't have any time dependency between them. So you can run your test in parallel. You don't have to wait for each other test to not happen in your environment. Of course, there are some problems that could occur with such with clock in Java. That clock has only static methods which creates another clock. So it's not very convenient for mocking. So we have to create additional configuration, additional class which extends the clock and have a method that's change the clock inside. I have said that we should avoid waiting unconditionally, but waiting conditionally is another thing, and it is acceptable. In Java, in JVM world, we have framework like Spock framework or awaitility. Awaitility is a library. And here, for example, in Spock, we can create polling conditions with specific definition of time periods that we have a timeout of 5 seconds, some initial delay, some factor, and we can use method PC eventually and pass some predicate, pass some closure here, and if the closure will evaluate to true, eventually evaluate to true, then we know that that something already happened. The bigger problem is with the method eventually not, because maybe the problem is not with the implementation of such method, because it's pretty easy to implement on your own. The bigger problem is that we are using the same pooling condition or the same configuration that we have in our in other tests which are waiting for something to happen. So with such tests where we are testing that something didn't happen, we should set the smallest available duration for waiting, not the default one. yeah, to not test and to not waste so much time. Another problem with time is that we could have external time dependency. What I mean, we could have some database scheduler. For example, in MongoDB, we have expiration indexes on the collections. We could have also some shared cron shared global time or something like that. And it's hard to mock them in many ways. So we should have all our durations configurable in our system. And even if our customer says that our creation date plus 30 days will always be the expiration date of our record, in our production code, we should always have a configurable such duration to have some expiration time duration injected in our test and set to the lowest available time period. Okay, another component that we are often interacting with is database. Here we can take advantage of the fake database. So instead of running the whole, I don't know, Oracle or Postgres or whatever you have, you can run, for example, some fake DB, like your own implementation of this specific interface when you are talking with database with HashMap as a base. You can, for example, use H2, HSQLDB, maybe SQLite. It's nice to use, of course, compatibility mode of such tools if it is available, but always you should have at least one test with the real database that you are using in production system. When you have chosen the database, now it's time to prepare it. And you have many points where you can prepare the data for your test. You can do this before each test in your suite. You can do this at the beginning of the suite, and then, for example, add all the data, create all the data that is needed. You can also do something before all the tests. For example, in Java, you can run Flyway or liquid migration to do that. Or you can even have something installed on the Docker before the test. So you are running with already prepared database before each build. And here, my advice is to prepare static parts only once. What I mean static parts, I mean any data definition language query like create table, create index, and so on and so forth should be created before and only once. And also any dictionary should be created in, for example, some initial data like dictionary should be created only once. And it's nice to load only the data that is needed for your application. So if you have a dictionary with 10,000 entries, maybe 1% of such data is enough to perform your test. When you are loading the data and have a specific market that you are doing integration test with database, maybe you don't need to load all the data whenever you extend some abstract class. Maybe you need them only for specific test cases. Another thing which is very important here is clean up data. And the main question is that if you have unique data, then maybe you never have to destroy the data, delete the data after using such database. But in most situations, we prefer to destroy, to clean up such data. And here we have many options. We can drop the table, truncate the table, maybe delete from the table all the data in the table. And we can also use the delete from with where clause. And the last option is the only one that can be used when we have parallel tests. And in my opinion, is the best way of deleting such data. But you have to be certain that you do not modify any shared data, and of course, you have to collect all the IDs that have been created during your test. Because, for example, and this is an example from my life, you have to watch out for the structures created dynamically. It's something that should be created only once. For example, the collections in some database in MongoDB, for example. Yeah. And at the end, we have made the decision that at the end of each of our tests, we will destroy the collection, drop it, and our framework will recreate it. The driver recreates connects it at the beginning of each test. And the problem was that our framework also added some expiration index to such collection, but we didn't tell our framework that in our test we are dropping such collections. So test that was using such expiration index, when it was running alone, it was working fine. When it was at the beginning of the test suite, it was working fine. But when it was in somewhere random place in your test suite, then it was failing. So it was a problem that wasn't very easy to spot, especially when you have a lot of such tests and you are destroying a lot of such collections. You don't know what has happened. Another thing which is very important when you are doing tests against some database is entity round trip test. And here, what I mean, you create some entity, for example, the movie entity, and you can save it in the database. And using the same repository, the same interface that you are using, you can get it from the database. The problem here is that, of course, it tests if your storing and restoring mechanism is working fine. But sometimes it's better to have a specific query, especially when you have some schemaless database, where you check if you are taking the data in a proper way from the database, and the data is saved in an expected way. Okay. Another component component set which we are using very often in our application are messaging systems. So here we have Apache Kafka, RabbitMQ, ActiveMQ, Artemis, even brokerless ZeroMQ, and here we have two connections. Yeah, we can get the message from the queue in our component. It's pretty easy. It's nice to have your own queue, of course, to not share it with someone else because you can consume the data which is not for you. And on the other side, we can push some data to some queue. And here it's nice, of course, to have your own queue where you are pushing the data, because if not, and we have a shared queue, then there is a problem how to check if the message was really published. So the problem is with the picking the message without destroying it and destroying another test check, for example, because such picking is not supported everywhere. So in Kafka, probably it works fine because it's distributed log, but in RabbitMQ or ActiveMQ, it's not so easy, because when the message was consumed by someone, then or picked by someone, then it was destroyed and you cannot read it again. And for that, you can queue it up again in the queue, or you can store it somewhere. And depending how you are sharing the state of your test, you can store it in some static variables, or you can store it in the database. For example, when you have to have access from many places to such data from the queue. The problem with the cleanup, I think it's pretty easy, because you can delete the queue, you can clear the queue. Of course, it doesn't work in a good way with the shared, when you are sharing the queue, or when you are running your test in parallel. But if you use the temporary queue, it's one of the best approaches, because no one else can access the same queue that you are using. Okay, next thing connected with the messaging systems is checking the message secret inside the application. And this is the problem that I have mentioned at the beginning, that, for example, we have component A, which talks with component B, using some queue in between. For such configuration, it's nice to, instead of having only one configuration of such queue in your production configuration, or any other configuration which is also very similar to any other, should be very similar on each environment, then you should have a specific output and input property, even if on production system it is set to the same value, because in your test it's much easier to test them in a separate way. Of course, you should have the test with the production configuration, or similar to production configuration, but it's also nice to have them tested separately. Another thing connected with messaging system is broker routing. So for example, in RabbitMQ, we can take advantage of exchanges which are not the direct exchanges, or in ActiveMQ, we have virtual destinations. So, I mean, we have component one, which sends the message to some queue, and the broker, based on its configuration, sends such message to queue for component A, queue for component C, and component B is, for example, not interested, and the message won't be delivered to its queue. And such configuration inside your broker should also be tested in your test to check if you are passing the messages in a good way. Okay, the next component that we are often talking to is HTTP. Okay. We are not only talking to, maybe such, we also expose such HTTP service. So for example, someone could ask us for handling HTTP request. For that, of course, we need HTTP server running on during our integration test, and of course in production. It's nice to have a different random ports, especially generated from not in unprivileged scope, unprivileged set of ports, and we should test against the same protocol that we are using in production. So to spot all the SSL problems, for example, in our product, in our application. When we have authentication authorization, we shouldn't use only admin account to check it. Maybe check it with anonymous access. Maybe check it with someone that has only some smaller set of roles available. Admin can do everything, and probably it won't check your security access in a proper way. If you are exposing some resources, for example, using REST, and you have different representation like XML and JSON, then test both the representation, not only one in your test, and for example left some representation only with smoke tests. Of course, we could also access some other resources available via HTTP. For that, our application, our test, needs some mock HTTP server. And we have a lot of implementation of such component. We can use mock server, wire mock, even at Talk, we have our own implementation of such mock server. And here, important is to decide where to run such mock server and how to set it up. So, for example, we can run a mock server at the beginning of each test with different ports, with different and even random ports. Or we can use such server because it's server, so probably you can run at the beginning of the test, and we can at the beginning all the tests, and you can turn it off at the end. And here you have to take the decision that you have your mocks defined up front at the beginning of the test, or you can add and maybe remove the test next, remove the mock after the test. But this is the option that is very crucial when you have unique tests, unique test data in your test. And thanks to that, you can run such mock several times in parallel environment. So it's nice to have such feature in your mock server. Another thing that is very important is to not use the same DTOs in test client that you are using in your production code. What I mean, in tests, for example, we are using order Java, where you have the definition of the JSON with some annotations, for example, and your framework converts such order Java to JSON. Such JSON is passed to your application, converted to order Java, and everything works fine. But the problem here is that when we change something in such order Java, for example, by refactoring, maybe change some letter, maybe fix some typo or similar things, we can break the API without failing our test, because it's in between. We are testing only the code in the test part, in the app part, and in such options, in such configuration, both classes are the same. The objects that were created from such classes are the same, and we receive the expected output. Yeah, and we are not checking the contract that we have in our JSON. So for such things where we are breaking the contract, we are knowing even about that, it's nice to have some contract tests. And contract tests, for example, using the Pact or Spring Contract module, you can have your contracts extracted in some other location, and both your components, the consumer and the provider of some service, test against such contract to test if they are working fine, they are not breaking the contract in a bad way. And yeah, it helps a lot, because especially when we are writing some mocks, we could have some typos and similar things, and it helps us to not failing in some bad behaviors. Okay, the next thing that we are often integrating with are files, and files could be, of course, used locally. And it's pretty easy. Of course, it's nice to do some cleanup after your test, or you can even mark your file in Java that you want to delete on exit, and during the turning off of JVM, such file will be destroyed. But if you are creating the files, it's always nice to have a specified directory where you can create them and do not think about that. And the nice thing is to use just the temporary directory that's available on your operating system. Even in Java, it's the API is already prepared for that and has specific method where you can create a temporary file or temporary directory with specific prefix, and the suffix will be generated randomly just for you. Random files are pretty easy, but the files available remotely are a bigger problem, yeah. And the problem that we had is that we didn't know what external file system we will be using for access some files in our application. Yeah, so maybe it will be configured in the future, or it should be pretty generic. Yeah, so for that, we take advantage of something which is called virtual file system. So to do not care that, for example, someone could configure FTP server on the other side, or WebDAV, which has happened in our case. And for that, we have a library called Apache Commons VFS, for example, in JVM World. In such library, we can get the VFS file system manager, call the resolve file on some URI. The URI, for example, could be the WebDAV, FTP, jar, whatever you have, whatever has specific controller in specific module in the VFS that we have installed, and we receive a common object like file object, and such file object has a lot of methods. So we end with pretty unified API, and we do not care about what is on the other side. But during our tests, we should care what is on the other side, because we have used the worst abstraction, worst implementation of such external thing that we could access. So in our test, we configured our external file system to just local temporary files. So when the WebDAV started to return some specific codes, when the number of files or number of directories was too big, we also received a specific problem, but only on production system, because in other places, it cannot be testable. Yeah, you don't have such restriction on your temporary system, and you do not create a lot of such data in your during your test on UAT or something similar. Yeah, and the only way to solve this problem was to download the Docker for WebDAV and test our code with specific test cases against the real WebDAV on the other side. Another thing that is connected with the files, and we have spotted the problem with, is mocking. When it's not easy to run a specific version and specific implementation of some external storage. For example, we wanted to use some S3 bucket, and we have found one of the S3 mock that looks good at the first sight, and we didn't check what it can do. And the problem was that it was imitating the API in a very good way, but it has a problem that it wasn't store any files even in memory, or I do not want to mention that it should store the data in some temporary directory. Even in the memory, the files wasn't stored. So we cannot have round-trip tests. We cannot save and restore such file from such mock. Yeah. So we have to rewrite all the tests just to test if our round trip is working in a proper way, because it was part of our scenario that we wanted to test in our tests. Okay, the next thing that we are often integrating with is cache. And with cache, the rule of thumb is to have unique keys in cache. If you are generating unique keys and put it in the cache, then no one else could access your key, and cannot override the value that you have right under such key. And also for your test, because your test should be pretty fast, then you can set the quick cache eviction. So even during your test, it should be very easy to test such scenario where you are putting something in the cache, and if it's, for example, has some expiration time in I don't know, maybe in seconds, maybe in milliseconds, then you can write a test when eventually in the cache the value is missing. The bigger problem here is always to have some remote cache, because in remote cache we should have some serialization around. Such caches stores the data in another format that we are using it in a local caches, where, for example, we could have something in the same representation that your language is using. So, for example, when you write such test where you create the key, create the value which is not the primitive type like string, integer, or double, and so on and so forth, and you put such thing in the cache, then you have to wait for clearing the local caches and be sure that such value will be get from another external remote available system to check if your serialization is working fine. Because if you didn't destroy any local caches in between, then you can receive the object that you have put in a moment ago, and the test won't be valid. And on production, you can check that, for example, when you are storing primitives, it will work, but for more complex object, there will be problem. Okay, I think that's all. To summarize the presentation, in my opinion, keep the test as fast as possible, not afraid to add new tests. Use the unique test data to have your test available for running in parallel. But also, it's very crucial to have the unique test data to test against the examples that you haven't think about. Yeah. So, for example, using good generators, which are not only generating the UIDs and also some, but also some specific characters with any Unicode characters, for example, can generate in such strings, then it could be better tested in your code. You can test against much more examples, much more cases. And because of the correctness, you should use as many real collaborators that you are working with in production as you can, yeah, to check if you are validating the real software on the other side, not only some specific mocks or specific dummy object that you have created for your test. Okay, I think that's all. If you have any question, that will be a perfect moment. I think on Hopin chat, it will be available for MC to ask me the question now.